So, Scott, once again, thank you so much for being a part of the program.
I'm a chef by trade, retired. I've always been interested in space, always followed NASA when they first started coming online with some of their documentation in the late 1990s. When everything was available online, I started reading all of their documents. They had their PDF files that they were providing on their report server and from their journal site. For years, I just kept reading all the technical data on their tests and progress, inventions, new technology, new materials, and everything else. And up until the mid-2000s, I thoroughly believed that they landed on the moon. I mean, I heard rumors here and there that it didn't happen and stuff.
Right.
I watched a couple of videos that really made me curious. So then I started downloading all of the photographs from the journal site and started to study them. And rather than look at what other people were doing and what their results were or what their findings were, I just stayed to myself because I wanted my results to be from my own findings. And the videos I've produced and the articles I've written are based on all of those findings. And you'll find them on the ALLA site. The videos are at Apollo Detectives and as well as Paul and the Flame.
Very nice. And of course, I noticed since the last time we talked, you have acquired some new friends, some new naysayers who want to debunk you now, Scott.
Oh, they're always out there. There's been a few new ones lately.
Right.
I would like to tell you that the research is continuing. I research all the time. That is my main thing. It doesn't matter where I need to look for the information on Apollo and NASA and things like that. I'll look anywhere to find out because it doesn't matter whether a person or a site has any credibility or not. Sometimes there's a little bit of truth in there, or there's some new information that I need to do some more research on. And I currently have a friend, and he went out and bought a bunch of vacuum equipment. So he can pull a vacuum of Tor to the -3 with the equipment. And he has taken the Hasselblad film, the actual Kodak ester film, and he's been putting it through vacuum tests in his chambers and developing the film. And I've witnessed all of it. I've watched him do the development, the photography, everything else. What it's going to show is that the film itself is being affected by the vacuum. The results will be presented by both Marcus Allen and David Percy. Will do an entire write-up on it when the tests are finalized.
I forgot to ask you, have you talked with Randy?
Yes, I have.
How's he doing?
I'm in his book.
Yeah.
He's going to do another chapter or so just on the photographs. We're working on that right now, as a matter of fact.
Very nice, very nice.
And he's getting some very good sales on his books as well. His first book, of course, is based on mainly the Saturn V rocket and the thrust and propulsion of the F1 engines.
Yes, that, of course, is the book, The Apollo Moon Missions, Hiding a Hoax in Plain Sight. A very, very good book.
Once you read that, you really have to question the ability to lift enough equipment into space with the amount of thrust that the Saturn V had. It really puts that into question, and anybody out there listening should buy his book and read it. He has done an incredible amount of research on the topic, and he's very knowledgeable.
That's pretty wild. And of course, as I was saying to you earlier, you do have some naysayers out there and people that are trying to debunk you, and you shouldn't exactly take it as a sign of disrespect. At least you got those people to open their minds just a little bit.
The fact of the matter that it may anger them,
sure,
doesn't change the fact. If in fact we did not land on the moon, which it's very much not just in my opinion, but it's very factual from the studies I've done that nobody landed there. If that upsets people, you have to just control your emotions and go back and just look at what my findings are and realize that these things are just so difficult to do. The fact that we're not doing it today is a very prime example that it didn't happen. That article you sent me just before the show.
Oh, yes.
is just another prime example of a delay.
Yeah, and we talked about this the last time you were here. We both, well, actually, I had asked you if you think they were going to push the date back, and what happened? They pushed
Yeah,
the
they've
date
done
back.
it again. They've done it again, and it's going to happen again. I mean, you realize they're not even talking about human spaceflight there. The 2024 Orion mission was unmanned, not a landing, just fly around.
By the way, Lee, if you didn't read the article, NASA basically wants to go to Mars over the moon.
Yeah, I did read that.
In the article, they want to take control of all of the equipment and have full control of the employees and the crew of the equipment so that they can compartmentalize the situation if they need to fake it.
Well, that way they can control the narrative. And,
That's right.
I think about Don Pettit, who was an astronaut, and they had asked him, and it's a famous video on YouTube, why we don't go back to the moon. And he said that he'd go back in quote unquote a nanosecond, but it's a painful process because when you really let that sink in, the idea that we haven't been back to the moon in almost 50 years and that NASA purposely destroyed all of the telemetry and all of the technology, quote unquote, they used to go to the moon. Really what it comes down to is that when I was growing up, the moon was televised on 3 networks and you believed Walter Cronkite. And all you had to do was convince Walter Cronkite that it was real and he would convince the world. And everything, in my opinion, is compartmentalized. The job I work at in logistics, there's many different compartments, and they do the same thing at NASA. Most people that work at NASA believe we landed on the moon and believe they're doing good work. But in the actual hierarchy at the top, it's compartmentalized, and they are not flying or have ever flown to the moon because it just can't be done. And they just keep kicking the can down the road.
Well, that's very apparent with the actual spacesuits. My article on Aulis is a complete breakdown of the development of the spacesuits through its inception, through Apollo, and right up to the new Artemis suit. And I don't know if you've watched the video when they were displaying the Artemis suit, and they had that woman come out on stage wearing the suit, and it was supposed to be pressurized to 8 psi, and she's opening and closing her hands and stuff. I mean, that's just a display model suit. She's not actually wearing a suit that is actually pressurized. She's wearing a pair of Nike boots, which they're not even sealed. So you can't pressurize the suit when she walks out on stage. The woman weighs maybe 45 kilograms, and you expect to see her bend down and pick a rock up with a 110 kilogram suit on. Absolutely impossible. The suit doesn't weigh that much. And if you go online, you can see the open contracts to actually make that suit. There's open bids available for contractors to actually build that suit, from the active seals, the computerized robotics to assist in the opening and closing of the gloves and that when the suit is pressurized, as well as the materials for insulation, abrasion, and micrometeor. They're all open bids there. They haven't actually built that suit. That's just a display model design of what the thing should look like.
It's just to keep the budget going. I think they're spending about $55 million a day. And I live on the Space Coast. I'm right down the road from NASA. So I'm in their backyard. But all of the numbers don't line up. The fact that allegedly the International Space Station is only flying at 400 miles above the Earth. And yet the moon is 238,000 miles from the Earth, allegedly. Why is it that we haven't gone back in almost 50 years, and now they're talking about Mars? And as you mentioned, they want to control the entire narrative. And the reason they want to do that is because they can't hide it in plain sight like they used to back in the 60s and early 70s. With all of the technology available and the internet and people like yourself constantly investigating this, they know they're going to be exposed as the frauds that they are. And so what they do is they compartmentalize it, keep shoving CGI photos down the throat of the public, and spending a lot of that money just on PR to propagate the continuation of their budget.
That's a interesting story about Gus Grissom. This one here, where allegedly he said a few minutes before he burned to death, he said, "Hey, you guys in the control center, get with it. You expect me to go to the moon, and you can't even maintain telephonic communications over 3 miles." Do you think he actually said that?
I think it was between 2 buildings.
Or between 2 buildings, yes. That's also something. Did he say that, though? Do you think so?
Yes, he did. And it is
Goodness.
recorded. You can watch a video on his last words.
My goodness.
It is online.
So that means NASA knew.
They knew exactly what they're doing. They
Yeah.
hired the best professionals in the world, remember? They don't make mistakes.
Allegedly. That also means that Walter Cronkite was also in on this.
Oh, absolutely.
Amazing.
You know exactly what's going on.
And of course, now I think we should get into some of the slides and photographs you had talked about in regards to the suit that they wore.
Okay, the very first photograph up there that you're looking at is the
glove, yes.
large gap in the glove, and the actual ring connection is at the base of that gauntlet where they connect. If the seal isn't connected to the suit, they're just using this as a costume to run around in. And if you're on Earth running around in a garment like that, you're going to get pretty hot. So you're going to want to get as much air in the suit as you can and hide it as much as possible. And if you look at that, you can see it's kind of pinned down on the front corner there, like at the front of the suit where the dirt is. It's just kind of pinned on there. But the actual, right down where you see the other band, where right at the glove between that and the gauntlet, that is exactly where the other ring connection is. So there's about 3 inches space between it there.
Oh, by the way, hold on one moment. Lee, can you see that photograph?
No, I can't. What do I need to do that?
I think I'm going to have to send you a link unless you are in the chat room. Sending it to you now.
Oh, okay.
Yeah, there you go. Yes, I just wanted you to follow along here. This is quite interesting stuff. The spacesuit is bizarre. And of course, the temperature on the moon is about 150 degrees during the lunar day, maybe even higher than that. I'm not even sure how that film even survived.
It's a boiling temperature if you were on the moon.
Right, and I'm just thinking, so how they use special film apparently, but I just don't think that would even sustain that sort of heat, let alone a live feed. My God.
That's why we're doing vacuum testing on the film itself. Because when you get to a certain level of vacuum, you start to get off-gassing of materials. Just as you put water into a vacuum chamber and it boils at room temperature, it'll boil away. So you have every material has its melting point, every material has a boiling point. The vacuum is replacing the temperature of the water to create it to boil at room temperature. So there's an association between temperature and vacuum or pressure, or lack of pressure. So if you bring the vacuum level down low enough, plastics melt in the 120 degree Celsius to about 240 if it's the S-star film, right? It'll start to melt at that point and it'll start to off-gas. And when it starts to off-gas, it's going to dry out. It's going to get very hard and brittle. And it will not roll up onto a film. And the emulsion that's in between the layers of plastic of the film is going to dry out, and you won't be able to take a picture with it because it'll just become hard. And we won't be able to photograph, right? Now, some of the film was outboard on the Apollo craft all the way from launch. The outside of the CSM, the data camera on the outside that took 1 frame per second, so-called, when they were orbiting the moon, stayed out there the entire trip to the moon while it was orbiting the moon, and it wasn't until they did a spacewalk to pick it up to bring it back inside before it was back into a pressurized system again. Now, if you look at this picture down, which is Neil Armstrong full suit, which is figure 4, if you look at the glove right there, when I was talking about the other glove, you can see the ring connections there. You can see the length of the gauntlet, and you can see where the ring actually is, where it actually has to connect together, right? When that gauntlet is up, there's a good 3 inches of space on that. So when you're looking at the top photograph and you can see the ring that's there, you know there's no way those two could be connected. The next series of photographs down here are running through the history of the initial stages of how the suit was developed through up until you get to the Apollo missions. And when you get down just past where Buzz is putting his sunglasses in his pocket there, the next photograph down there, this is an example of how the suit should be made. You're looking at a suit with an outer abrasion suit and an inner bladder with flexible joints in it and stuff like that. But the suit that is on display, the Figure 4 suit, doesn't have any of that inner bladder inside of it. And as we scroll down a little farther through the different suits, you get down to Figure 10. If you scroll down to Figure 10,
Figure 10, okay.
That. Now you can see that inner bladder is not inside that suit. They just have a foam comfort layer, and you're looking at the back of the suit with a zipper there, and the ring, of course, that steel ring has to be sealed to the suit. And that's the back side of the suit, and the zipper comes up there, and there's a great big gap. You can't pressurize that suit. The air is going to escape right out the back of it. It's not even sealed to it. The ring is not sealed to the entire suit. And that bubble helmet is so-called sealing onto that red ring. And the only thing that's holding that on, those are just like door hinge clips. They just snap in and out. There's no way to compress the seal. And when you're in that level of vacuum, not only do you have to compress the seals would have to be made out of steel, not rubber. You get beyond a torr value of 10 to the minus 6, and you can't use rubber anymore. You have to now use metal seals, and one-time use only metal seals when you're out that far. And to give everybody an idea where torr value of 10 to the minus 6 vacuum is, that is 130 miles off the surface of the Earth. You go out beyond that, and it really gets severe. You're into a really hard vacuum. And now the International Space Station is sitting at 255 miles, 400 kilometers, and you're at a torr value of 10 to the minus 7. You're already getting into off-gassing. You have to use one-time only seals on it. You do a spacewalk. If you went out through your airlock chambers, before you come back in, you would have to have brand new seals on it before you could lock the door and seal it again, or it wouldn't seal.
And just for the sake of conversation, why would NASA go through all the trouble to fake the moon landing?
Had to prove that they were the most powerful nation in the world. They had the highest technology. Basically, the Apollo and NASA were a military mission. They were all military men, right, that were working for it. It's a military operation. They made it look like it was an independent space mission on a different type of mission, but the idea was to prove to the world that they were the most powerful nation out there.
Even more important than just the wet flag, this is from the slideshow, by the way, Scott. And
yes,
this is from the water. You could see water is peeling up the paint between the glass.
Oh yeah, that's been there for quite a while. Why would they put a rain guard on the outside of a spacecraft?
That's crazy.
Yeah. Was there a cold front hitting the moon that day?
In the PowerPoint presentation, that would be slide 34, I believe.
Oh, okay, I'm looking at it.
One of the most devastating things, of course, are the images of water in a vacuum. And of course, there's absolutely no way that there'd be any standing water.
There shouldn't be moisture at all.
Even if they did a simulation and had a bit of a vacuum in a controlled room to try and reproduce it, right? They wouldn't be able to actually do that. The one that really, this one here.
Yeah, I do have that now, by the way, for those in the chat room. The flag photograph is up there in the chat room, and you could clearly see that the American flag is showing a wet spot there. It's quite big, actually. It goes all the way around.
This one is also interesting because it just shows you the equipment was, of course, prepared in a clean room, loaded on a spacecraft, sent to the moon, and they dragged it out, opened it up, and then took a picture of it. And that last image that I showed you of the seismic experiment, there's actually standing water on it. Plus, you can see where there's mold and where the water has dried back with the dirt on it. This has just been sitting outside on a simulation set, and it's been used over and over and over again until they did the final simulations. They never bothered to put it away. They never bothered to clean it up. They didn't do anything.
The equipment left outside to whether NASA is using these same props until it is in such bad shape. And that's kind of what we went over the last program, that they recycle their equipment.
Yeah, it's a very important feature that they were using the same set for all 6 missions. And that is part of my research and findings, right? And this is just one example of it. Every piece of equipment is being used over and over again. It's the exact same LEM for all 6 missions that you're looking at. And Apollo 16, when it took off, they blew the side panels off the thing. And Apollo 17, they have replaced the panels on the side and put a few things on. The bell housing was damaged in Apollo 15, and it's still the same damaged bell housing in Apollo 17. Exactly the same crinkled. Apollo 15, they actually dropped it while they were doing the simulations. And if you watch any of my videos, if you put in Faking Space Season 2, it's on the Apollo Detectives site, and that video has been put together as one video. The main parts of my research are all in that one video.
And now, for fun, I do have a animated GIF up in the chat room now of the American flag just there, waving around, while the astronauts just walk around.
Is that Apollo 16 when they're shooting by them?
I believe so.
Yeah.
I think it is.
Yeah, and people are saying, oh, they touched it, or it's static, or whatever, right?
Mm-hmm.
Not highly likely.
What do you think of that, Lee? These photographs?
They're
interesting, right?
Yeah, they're just another layer of evidence that proves we never went to the moon.
What my research is doing is showing you exactly how they prepared the set, how they photographed it, and the exact equipment. Like everything is non-functional equipment that they were using. They were just props for the set, right? All the experimental equipment is just hooked up with an orange band. There's no actual wires in the cable, right? And they just stick them on the bottom of a frame. They're not plugged into anything. And the astronauts, because they wanted to expose the fraud, they took the central station, which is just a square box with foil on it, and they opened the foil up because it was collecting all the data from all of the other experiments. There should be all kinds of equipment in there to collect the data, digitize it, and then transmit it back to Earth. And it would have a great big battery in there, about 1.5 times the size of a car battery is supposed to be in there to power it. Great big computer, and all this collection data and so-called hard drives long before a hard drive was invented. And then all the equipment to actually transmit it back. And it doesn't even have an antenna to send the signal back with, right? But they ripped the foil off and showed it. There's nothing inside.
Now, by the way, Scott, I have one of the most interesting slides and photographs up from your PowerPoint presentation. That would be slide 40 of the can of beer. And yet again, it goes back to Quebec, back to what Casing mentioned about some of the various stages.
Well, of course, Canada had some participation in the Apollo missions because they actually made the landing legs for the Eagle. They're the guys that designed those folding legs in that lightweight aluminum on there. The beer can just happens to be parked there for someone to take a picture of, one of the whistleblower astronauts, right? When they're out on the set, somebody just dropped one in the dirt there.
One of your naysayers, by the way, Scott, in a video was mentioning this beer can photograph and saying this was purely pareidolia.
It really looks like that, doesn't it? Right? There isn't a footprint around. I mean, you can't have a piece of metal on the lunar surface that reflects like that and has a label on the side of it. And I don't care how you do it. He can call me a liar all he wants. That's a beer can, you know? And he can show it to all of his friends, and they can tell him the difference. Right? And that's the same with all of the other images out there and the cars and everything else. Right? If you don't believe me, show it to your friends.
We haven't even talked about Buzz Aldrin's watch yet. My goodness, another great photograph we'll talk in a minute about here.
Yes, well, I haven't looked up all the watches and the times on the different ones where you can actually see the time on the watch and compared them to the journal files when the photograph was taken. That particular image there shows the difference between Apollo 11 and Apollo 15 where they've put the rover in, and it folds up into that area, and it has swing arms that pull it down, the wheels pop open, it unfolds, and the way it was supposed to run. And of course, they would have practiced that and made it work. They would have built that thing and made it work so that it would unload and operate like that to the ground here. But then they would have to put the batteries in, and they'd have to put the seats in, and then all the other equipment on board. It would probably take a couple of hours, even if you're doing a simulation, to get the thing set up properly. There is one video. It takes nearly an hour for them to get it unloaded. Time-wise, on Apollo 15, they claim they had it in about 17 minutes and driving it around.
Yeah, but if you're doing it on a sound stage, it's a lot quicker.
Yeah, well, that's what I mean. The simulation of them showing it on the ground, just in practice, was over an hour to get it set up.
Yeah.
But they did it in 17 minutes when they got to the moon. So they got quicker when they got up there. I guess it's lighter.
And now we have the photograph up in the chat room of Buzz Aldrin's watch.
Yeah, it's interesting the time, because they should be on UTC time because they're being tracked so-called worldwide, and the communication links are coming through from everywhere, so they'd be on universal time. That watch is exactly set at Flagstaff time. Okay.
That's pretty good.
Are you seeing the photograph now, Lee?
I'm on Skype right now. I also Googled it.
If you look at the journal log when the actual photograph was taken, it's actually at Flagstaff time because that's where they were doing the simulation. And of course, his watch would be set to that time because that's where they were. And that's just another verification of where they were when the simulation was taken.
So was the moon landing shot on a soundstage, or was it shot outside?
They would have shot the descent in studios, the orbit of the moon, the translunar injection, all of that would have been shot indoor. They were using those large models and their rail tracks that you see, those images they have of those, and their maps, those were all done inside. Everything the astronauts were doing, as far as I'm concerned, were done strictly outdoors. When you see the water, when you see the damage, when you see the paint peeling off, like when you get to Apollo 16, the paint's peeling off it everywhere on the outside. It's just left outside in the sun.
Right.
They didn't even bother to take it inside. And when you get into the rover and you need a larger set, that's where Cinder Lake comes in, right? That's where they're running around. That's where they built the model of Hadley Rill. And if you look at the images of Hadley Rill, they're standing beside a rill that is supposed to be 1,200 feet deep, or approximately the same height as the Empire State Building, straight down and a mile across. The simulation set for the rill that they built is about 150 or 60 feet across and about 60 feet down, and that's what you actually see in the photographs. And you can compare that using the physical size of the rover sitting at the side of the rill. I mean, at 1,200 feet, you wouldn't be able to see the rocks. You can see very clearly defined rocks on it. That rill is approximately the same width as Meteor Crater in Arizona, and over twice as deep. You look at any of the photographs of Hadley Rill, and it's not even close, but it's about the same size as they built for the simulation at Flagstaff on Cinder Lake.
And just for fun, what would convince you that we did go to the moon?
If I could have lunch at Donald Trump's Plaza Hotel, on the lunar surface.
I like that. So back to the crux of things here. Back to the NASA Apollo moon missions here that we firmly believe did not happen.
Right. You wanted to look at the watch.
Yes, let's go back to the watch.
And there's another image of the watch that I have, which is 65 in the presentation.
Ah, okay. I see it now.
Because that relates a little more closely to what we were talking about, these spacesuits just being costumes.
Yes, sir.
And you can see that on the top picture there, they shot down the glove. You can see how far that ring is down inside that gauntlet. And so that's just right about where the watch band would be. And then the red ring, which is on the sleeve, is about 3.5 inches apart. It simply isn't connected on that suit. And that watch, of course, is 14 minutes after 11. Absolute Flagstaff time that it's on. And it should be on UTC time, which it would be actually 14 minutes after 4 o'clock in the morning, is what the watch should say.
Yes, it's another interesting piece of the puzzle here.
Yes, and we have a friend of mine listening for sure from Australia. I'd like to say hi to Tim.
Oh yeah, greetings.
He's out there listening. He's a film expert, by the way, in the movie industry. And he actually showed me exactly how to do the simulations for the landing and everything else for the Apollo missions. He showed me quite technically how to do that. And he was using the Superman video as an example of how to make something fly.
But yes, now we are back to looking at Buzz Aldrin's glove here with the watch.
If you look at the timeline and when that photograph was taken, that photograph was taken 56 minutes after he set foot on the surface of the moon. He set foot on the surface of the moon 3:16 UTC time. So it's an hour. It's 56 minutes after that when this photograph was taken, after he set foot on the moon. So it should be basically 4:14 is what the watch should say, and it says 14 minutes after 11, which is Arizona time.
Is it safe to say they were busted?
They've been busted up, down, left, right, and sideways, and nobody will believe them. And I mean, that's been going on for 40 years. I mean, by the time you get into the early 2000s, when Marcus Allen and David Percy did all the photographic examinations and everything else that really proved that it was on a set with the multiple lighting and the shadows and everything else, right? And what Bart Sabrell has produced, how it was being filmed and how they inserted the image of the Earth in the window and stuff like that, people still don't believe it. So all of those people are encouraging me to come ahead with the evidence that I now have, showing exactly how this thing was set up, how the timeline, when they were there, all of the photographs with the color plates and the actual date and everything else on it. I mean, it has the photographer right on the color plate who is doing the shooting of the film. Not only on the film, but it's on all of the photographs, all the magazine photographs, right? Those color plates are there for every one of them, and they're all available online. NASA's not hiding it. That's the interesting thing. Slide 12 is the color plate for Apollo 17. And the date on there is actually a couple of weeks before they even took off. November 28th, 1972, right? And then when you look at the rest of the detail, it shows you the camera and everything else on it. But it also has the photographer and the inspector right there. I mean, those people were not on the moon. So why would their name be on the color plate? And the other thing is people say, oh, well, they did the color calibration before they took off. That was done beforehand. Well, that's impossible, because if you did a color calibration on Earth for the magazine for the camera, and then you stepped into space, you're now going to get the full spectrum of light, included UV light, which completely alters the color of everything, right? Black light. If you're below the ozone layer and everything else is filtering out all that UV light on Earth, you wouldn't be able to do the color calibration and have anything come out. If you're on the moon, you're going to have the full spectrum. It would have to be calibrated there if they did a color calibration. And those people wouldn't be involved.
By the way, you saw the video of that rendition from NVIDIA, that the video game graphic card company where they basically mapped out the moon.
Yes, and they absolutely got it right. They did it just like any other photocopier. They took an image and they reproduced it and digitized the whole thing with their software. Did exactly as when that sunlight is shining there, they reproduced the diffusion of light through atmosphere coming off the sun. They got it exactly right.
That's pretty crazy, right?
Well, they were trying to prove that the reflective light was coming up against the spacesuit. They forgot that the sun should just be one bright light. It shouldn't have any diffusion of light coming off of it. And they got that big halo around the sun. And that wouldn't happen in space. That only happens if you're in Earth's atmosphere. They reproduced it 100% and proved that it was on the Earth.
I don't think I mentioned that to you during our last interview about that company sort of recreating the moon landing here.
You can animate anything, right?
That's right. They just proved they could easily be faked.
They just proved that you could fake it through animation.
Right.
But Disney was doing that before anyway.
How ironic. It seemed like a lot of them were sort of, some of them really didn't believe we went either.
You have to realize that NVIDIA had a contract with NASA to produce graphic cards and cameras and stuff like that, right? Capture cards.
Very good cards, by the way.
Yes, they are. I use them all the time. They're excellent. That's how I look at the photographs, using their technology to find all this stuff. But they actually canceled the contract to produce anything for them because they could not meet the requirements. The radiation was just destroying their cards. It's on NASA's report server. Has all the test results from laptops, screen displays, and video cards are all on there. And I think the best laptop that they had lasted 43 seconds before the radiation took it out. This particular photograph here on the slide 27 is the actual lowering strap that they used for the simulation to lower it down on the gantry crane, right? And there'd be 4 of these straps, and they were attached at the top of the landing legs. And you see the shape that they can just loop on and hook onto them, so when they lower it down, when they relax, they just slide off again. They used the hammer and the feather and dropped that, so when they took the photograph of the hammer and feather, they were able to capture the actual gantry strap in there, right? And of course, nobody notices that the gantry strap is there. They're looking at the hammer and the feather, right? This is how the astronauts were able to photograph all of the fraud within the simulations. It's a prime example. They are the whistleblowers. They were showing you the damage that was done. When they took the photograph underneath the Apollo 15 to show you all the damage that's there from that. All of the other equipment in the related photos around it, the stuff is just thrown all over the ground. People criticize me and they go, well, why would they do that? Right? Well, these people were really upset. 3 of their friends died. And the only thing they had, they couldn't go to the media or anything else. The only thing they had available, the astronauts, to document the fraud, to document that it was just a simulation, that it wasn't the real thing, were the Hasselblad cameras. And those were just props for them. The professional photographs with the Hasselblads were done by professional photographers, and those were maybe 3 or 4 dozen that were used for media purposes only, for magazine, newspapers, whatever. The rest of the time they're out there, they had them just as a prop on their chest, but they were actually working cameras. And they just kept taking photographs of everything they could out on the set. So if there's a piece of metal sticking up out of the ground, or if it wasn't, they'd dig it up and take a picture of it. They kick open a rock, if it's got spark plugs in it, there's rocks in it. If somebody left a beer can laying around, they took a picture of it. There are no random photographs. These guys were very dedicated in defending the lives because of the deaths of their 3 comrades. That's exactly what they were doing with these cameras. And they were risking the lives of themselves and their families at the same time while they were doing this. Another good example of the simulation cards are the cue cards, which we haven't talked about.
Ah, yes, the cue cards.
which is
way up there.
10. They're pretty good examples of it right there. Basically, these are little cue cards for the astronauts because it has the exact time that they have to shoot it because they only have so much on the camera. They got 4 minutes of film. So time is there that they have to shoot it. The camera settings are there for them, where they're going to be standing. All the rock locations are there. I mean, if you're supposed to be on the moon, you can't have these details in there. What should be in the cue cards for them is all the metering for their life support systems. This particular cue card gives them a description of what they're supposed to say on camera on what the mineral contents were when they walk up to a rock and crack it open. It shows them which direction the sun is going to be. I don't know how you know which direction this rock is going to be sitting. All of that's there. That is just to shoot a scene. That's exactly what those cue cards are for. And of course, in number 11, that is for the Grand Prix. That's where they drive the rover around. It's called the Grand Prix. You can get it online. And it shows where the cameras are going to be positioned. It shows where the craters are that they drive through, one around the two and then around the last one and park it. And that's exactly what you see in the video. That's for Apollo 17. It actually has Jones, and that's the guy that's in Apollo 17 who's the inspector. That shows where he's going to be standing, so you don't want to get him in the shot. Right? I mean, with the helmets on, they couldn't even do hand signals because they're blocking half of their view. So for each different scene that they set up, for each station that they're at, and everything that they're going to find and document is already filled in months ahead of time on these cue cards. And they're done there so they could practice it in the first place and do it for the final simulation. I mean, even the timeline when they're driving the rover, I don't care where you are. If
Right.
you're driving a bush buggy, you can't tell me that you're going to be there right to the second to the next spot where you're going to stop. This shot here from Apollo 16 also has lettering on a rock. When you go out to a driving range and you grab a bag full of balls, 100 balls, they used to make little ones for golf courses that look like little golf bags. And because it's owned by the golf course, GC's golf course. Right on the bottom of it.
I think I remember you saying they were even playing golf at one time.
There are golf balls all over the set everywhere. What do you think these guys are going to do in their spare time when they're building the set and they're out there? It's just a big driving range for them. The initial shots in Apollo 11, the very first shots before they even got out, there's golf balls all over the place. And that's not there. It's everywhere. Almost any shot you can find golf balls on the set. You just need a good NVIDIA graphic card. Turn the DSR up and away you go. 45 is the sea rock, is found in Apollo 16, but the photograph on the left is Apollo 11, and that arrow is showing is the same rock in Apollo 11. They're on the same set in Apollo 11 as they are in 16. Approximately the same spot. That was a pretty big gantry crane. They didn't move that around much. That thing's about 300 feet wide and 600 feet long and 200 feet high. For simulation, it could lift the lander 180 feet in the air and come down on the simulation. And there's even videos showing how it works online. And it was all set up at Flagstaff on Cinder Lake. But that sea rock is there. That rock is in every Apollo mission. I'm showing it at 11. That's it in 16 is the sea rock. Anybody else wants to do the research through these photographs and do the study that I have and find them, all you have to do is send me the file numbers when you find the rock. And then I'll know you've done this research.
Take us through slide 53 now.
That is the Sandusky vacuum chamber, the Glenn Research building in Sandusky. And that building was, I think, $1.6 billion in 1969. It'll pull a torr value of 10 to the minus 6, 130 miles off the surface of the Earth. No human being or spacesuit has ever been tested in it. They put other equipment in and test and see what the off-gassing and everything else is on it. But what I'm showing in the photograph are the 8-foot thick concrete walls plus another 2 feet of aluminum and steel plus a titanium sealing ring in there to hold back 1 atmosphere on the outside to a toward of the -6 vacuum on the inside. You need that much structure. And now you have to believe that that spacesuit on the left-hand side is as structurally as strong as that building is and still remain flexible.
It's interesting, really.
People just say, well, it's 1 atmosphere, 14.5 psi, and when they get a hole in the space station, they'll take a canister with 15 pounds of air in it, and they'll open it up, and they'll say that's how fast the air goes out. And that's how they claim the space station would leak down at. But we have other examples on Earth that you can use.
That's true.
A slight variance in the barometric pressure, if you happen to be in Florida, and the 2 pressure differentials are there, which is maybe 1/4 of a psi, is sitting out there over the ocean. When those 2 lock together and try to equalize themselves, I mean, it creates a hurricane that'll rip your house to the ground or take your car for a little bit of a flight, right, and knock it into your neighbor's yard. That is the power of the differential of air pressure. Another good example of a vacuum against an atmosphere is a lightning strike. When that lightning comes down, it splits the air, and it comes back together, you hear that clap of thunder. Scientists and everybody else say a vacuum does not suck. Well, that may be true. It can't suck on nothing because there's absolutely nothing there. But when we put something in an atmosphere, like a container with air pressure in it, has air mass, air molecules, if that air tries to escape, they claim that the vacuum doesn't suck. So it has free space that it can run into, and it will accelerate in a molecular free space close to the speed of light. And the effect of that, if you had a hole in there, everything's going to collapse so fast it'll be like an explosion going off. These are examples of the type of seals that you need to use here on Earth to create a vacuum. Like when you get out past a torr value of 10 to the -6, you're into metal seals, and they have to be compressed down tightly to hold that seal. They can't be active seals. They can't turn. Like when you look at the new design of the Artemis suit, the thing slides back and forth at the waist round. Those are active seals sliding back and forth. They will work up to a certain level of vacuum, but certainly once you get out into space, they're not going to be functional at all. As soon as you turn them, they'll just start to leak. And they can't be rubber because they'll just tear right off. But when you see that kind of a seal, and then they tell you with that kind of compression on it, and they tell you that a vacuum doesn't have any force. Well, they're trying to compare the force of a vacuum to PSI. There are 2 different scales completely, and people need to understand that. The torr scale is a measurement of the force of the vacuum. PSI is measurement of molecular structure. And if you also try to compare a vacuum to being underwater, underwater is completely different. When you're underwater and you're in a suit, the structure of the suit really doesn't matter. As long as you compress the air inside the suit to match the pressure of the water outside, the suit itself has 0 pressure against it. There's nothing happening with the suit. It's only when you have a differential that it has to make up. When you're in space, the suit itself has to maintain the entire force of the air pressure inside plus the differential of the vacuum. And the vacuum is infinite. The force of the vacuum is infinite. Even Einstein said a teaspoon of a pure vacuum is stronger than the total force of the entire universe. It's absolutely infinite. And as you go out through the atmosphere, and this is where people don't understand how very little we are traveling into space. We're traveling in the upper atmosphere is what we're doing. When you get up to the top of Mount Everest, you've already reduced the air pressure down to the point where you actually need oxygen as a human to breathe. When you're in an airplane at 35,000 feet, the reason why they don't fly higher than that, because it's far too dangerous for commercial aircraft to fly higher than that at this time. 39,000 feet up is called the coffin line. Like the layers of the atmosphere are defined, they are as defined as water to air, like the surface of a lake to air. There's just that much less dense when you hit these layers. The coffin line is called the coffin line because if you fly above that in a normal aircraft, the aircraft becomes unstable because there isn't enough air across the wings to create lift. The only way you can fly across above the Kármán line is you must be supersonic.
And I have a photograph of Alan Bean from Apollo 12 using the fuel transfer tool. That's despite the pressurized gloves having mostly no mobility.
The thing is you're in a full simulation and those gloves can function beautifully because they're not pressurized, right?
Right.
Most of the documentation from NASA claims that they couldn't grasp a hold of anything under an inch. Their thumb and their finger would be an inch apart. They couldn't grasp anything smaller than that. It had to be an inch in diameter for them to be able to grab a hold of something. They couldn't handle very fine tools or machinery, and they didn't have any really with them. That's where the Artemis suit, the contracts are out for the robotic assist to open and close the gloves. Still hasn't been designed. 50 years later, still hasn't been designed.
And we haven't even gone back to the moon.
Well, we haven't gone back to the moon because they're afraid to simulate it. We'll find out. Anyone looking into the NASA documents, anything in the last 10 or 15 years, they're working with Boeing and Grumman and a few other companies. They're developing engines for commercial flight, airplanes, right? And they're looking at supersonic and hypersonic drive engines. Our skies are so full of planes right now, they need more space. They need to be able to fly higher and faster. So they need that 40 to 50,000 feet and that 50 to 60,000 feet in there for super and hypersonic flight. That's the two different things. And they need two different types of engines to fly in those ranges because of the lack of oxygen. And that is what you're going to find if you go looking through the documentation from NASA. That is their focus. It is not on traveling to the moon. It's not traveling to Mars. It's not anything. They're working with those companies for commercial air flight. The problem that they have when you get up above that 39,000 feet is if you have a leak in an aircraft, if you have a window blowout, if the pressure goes down, you don't need to have the oxygen mask come down. You are a low enough vacuum at that height, you will just simply die within seconds. You're fully embolize your blood, you just boil it. No second chance, there would be no survivors, there'd be no nothing. And that is the problem with flying higher than that. If they have an accident, there's no give at that height. And that's why at 35,000 feet they can drop down oxygen mask, get the height down, and you'll still be alive. That's where the money's going to, that's where the focus is. That photograph 57 is taken right from a press kit. It's also in the Lunar Journal as well, showing the flight path, and it also in those files has a complete description on the telemetry that they were expecting. It doesn't have the actual data of the telemetry, but it shows exactly the flight path that the craft was taking. And the only way you can do a translunar injection is you must be in line behind the Earth at the equator to shoot to the moon. You have to be exactly on the backside of that. You can't be in a different flight path. And if you go to NEN 58, it now shows a different flight path.
Ah, yes.
And you got to realize the millions of people that watch the launch. This thing's showing it launching and going across the United States, not out over the Atlantic. Then you take the next number 59. Now it shows you go partway around the Earth and then turn left and go up and over and down and around and out and shoot underneath the South Pole to go to the moon. You physically have to use a lot of fuel to stop the direction you're going and a whole lot more fuel to take it off in a different direction. Even the translunar injection to escape the gravitational pull of the Earth is somewhere to launch it, even if you're on a normal path, is 260, 280 tons of fuel that you need extra. that they did not have. And there are lots of mathematicians out there that have worked that out, which means you'd need 2 more Saturn V launches into low Earth orbit just to provide the fuel to do the translunar injection. 64 is another example of them trying to lie their way out of the Van Allen belts, showing that they skirted around the outside. Like the Saturn V rocket was claimed to have lifted 130 tons of cargo. That's its maximum. You need another 300 tons just to do that maneuver right there.
Yeah, I see that now.
And anytime you make a maneuver in space, you're going to use a lot of fuel. You have no other friction. It's not like driving a car. You can't turn the wheel and it continues on there. If you give it a little blast, it'll rotate the crash. You're still traveling the same speed. And you're not traveling at little speed. You're traveling at 12 kilometers a second. And you've got 130 tons you've got to slow down. That's like putting bicycle brakes on a train. And of course, once you change it one way, then you have to stop it from doing that again by more fuel, right? And they do know that.
And what would be the significance of the mission Apollo 11?
The Apollo 11 mission was to prove that the United States was a superior nation in all of its technology and as a military force. Not only that they could go to the moon, but they could be in space, just like the Space Force, right? And control the planet with physical force from space. It shouldn't be off trying to say, oh, we're going to the moon, we're going to Mars, we're doing this, we're doing that, right? Because we all know the Orion spacecraft have been sitting around for 10 years and they're still trying to fix a couple of heat shields. I mean, that's longer than the entire Apollo missions all put together just to fix a heat shield. So where's the snag there? But it's a double-edged sword at the same time, because if you tell all of these people that all of this technology already exists that you can go there, then those guys aren't going to invent it.
Yeah, it's a hit and miss.
Double-edged sword.
By the way, Scott, I just wanted to jump in here really quickly and add on to something. Well, not even to add on to something. I don't think we've ever even mentioned Apollo 13 and what caused that accident. I don't think we've ever talked about that, me and you, Scott.
Well, it's pretty simple when you read through all of the data. It got pretty high. Oxygen tank exploded in the upper atmosphere. It separated, landed in the Atlantic Ocean. The Russians picked up the capsule the next morning and handed it back to the U.S. It never did the flight around like you see in the movies. And when they picked that capsule up, there was nobody on board. It was an empty shell. I mean, it's documented. It was in the Russian newspapers.
What was it initially that first made you question what you saw?
I think the first video I watched that really, really got my attention was James Collier. It was 1997. It raised way too many questions. The second one I watched was Marcus Allen.
Marcus Allen.
That's what I said. I've got to look into this myself. When you believe something, when you believe they landed on the moon, like I said, I grew up in high school. I was just flooded with it. Those kind of things. So when you believe it your entire life, looking at all the documentation of NASA, when you read it and you believe, you don't see anything wrong with the documentation, right?
Right.
It all looks good. Oh, here's the test results. Okay, there was a failure here. Well, they must have corrected it. They're showing you that this was a failure, that was a failure, and this had to be done, and they had problems with the wiring and this and that and the other. Well, of course they must have fixed it, because they're all PhDs, engineers, everything else, right? Of course they fixed it because they went to the moon. It must have happened. You don't even question it.
Yeah, it was on TV, so of course it was real.
Right. And then James Collier, you sit there and listen to it and they go, well, why did they destroy all the data? Why is this? Why won't that guy let me have a look inside there to see how big that is, to see if it's even big enough for him to get out of? This thing looks like it's put together like a piece of garbage. And in fact, it is. Right? And when I watched one of Marcus Allen's presentations, and he's going through the fact that this is an actual studio setting, and there's the additional lighting. But I'd like to thank David Percy for taking me seriously, because I probably came out of the blue. He's been around forever, right? It's not that I wasn't there. I just wasn't expressing myself publicly to anybody else. And people need to know. People need to understand. We need to know the truth. We need to know where the lines are, what we need to develop, because it all comes back to where we live. We have to pay more attention to the corporations that go out and destroy this planet, especially the mining companies, oil companies. They can go out and destroy the planet, and people will say, oh, don't worry about it. They made a big mess there. We went to the moon, for God's sakes. We can certainly clean that up. Actually, no, we can't clean it up. We didn't go to the moon, and we're going to leave it with our children and our grandchildren to deal with.